Welcome back, friends, to Math Mini Lesson. This is our lesson on area of rectangles with fractional edges. You've done area of rectangles probably since third grade. We've always started with simple numbers. Now we're going to look at it with fractions as our dimensions. So as I model, look to see how I represent the multiplication sentence with an area model and vice versa. How I accurately calculate the area of a rectangle with fractional dimensions, and how I express area in simplest form and with the proper unit squared. So this, because we're talking about area, we know we usually multiply length times width. Now it's just for fractions. So let's look at our first example here. What are the dimensions of the shaded part of this rectangle? So this is not asking us about the area, just the dimensions themselves. And the way I would look at this is I see a piece of a piece. So the small part here, what does that represent? So how can we figure out what the length and width actually are here when I don't have a whole piece? So one way to look at this is to just look this way and think, what fraction do you notice here? If you're just looking at this one column, I see 1 out of 2 pieces. So I can represent this as 1/2. And over on this side, if again, you're only looking at this one row right here, and I see 3 out of all 5 pieces, so 3/5. So this is one way of being able to recognize, oh, that 5 doesn't look like a 5. I want to be super clear for everyone. So this is just one way of being able to just figure out the dimensions when you're given a model that doesn't have clear numbers on it. Another way you could think about this, because sometimes kids don't see the 1/2, and it's with shading. So I'm going to use 2 different colors to kind of shade. Starting with this one here on the side. It could be that I'm just shading, I notice that this 1/2 is the dimension I'm talking about, just 1/2. And then going in the opposite direction down, the 3/5. So 3/5 of my rectangle shaded this way. Notice that they both overlap into this area. So this is just another way of showing area, and we call this like an array model, where I can see the pieces here, where again, I just shaded 1/2 here, and then I shaded 3 out of 5 here. And where they overlap is the area of this part here, which is something we can figure out. So that's how we would just do the dimensions. But if I wanted the area, I just would have to multiply these 2 numbers. And I get 3 out of 10, which is exactly what we're seeing here. We have 3 pieces out of all 10. All right, so I hope this is really helpful because you're sometimes going to be given a model that doesn't have dimensions on it. And now you know how to look at it from 2 different ways. You're going to have to look at it in this direction, look at it horizontally, what fraction do you have, and then look at it vertically to identify what fractional pieces you have. Hit pause and jot this down into your notes. Here's our second model problem. I'm going to highlight in yellow. A tabletop is completely covered with square tiles as shown below. Each square tile has the same length of 1/2 a foot. So that's how much each of these little squares are. They're 1/2 by 1/2. What is the area in square feet of the tabletop? I love this problem because it's a little tricky, but not tricky enough to get us. When we were younger, we would just count all these little squares, but that mattered when one square was equal to like 1 unit. Here, that's not the case. This is equal to 1/2 a unit by 1/2 a unit. So it's a little bit trickier. We're still going to find the length and the width, but we're going to use what we know. So let's start this way. And I'm going to use my repeated multiplication. I know that I have 5 groups of 1/2. So 5 times 1/2, that tells me that this dimension is 5/2. And in this dimension here, I have 1, 2, 3, 4, 5, 6, 7 groups of 1/2. So 7 times 1/2 is I have 7/2. So now I know my dimensions. I know what they are. And these are both, let's make sure we have our units here, feet. So my question is, what I have to solve is, what is the area in square feet? Well, I know that that's just length times width. So 5/2 times 7/2 is 35/4 square feet, which you possibly could leave as an answer, but I like going through things completely. Like, let's just completely turn this to a mixed number. 35 divided by 4. Well, 4 times 8 is 32, so I know that's 8. And 32 means I have 3 left over. So 3 left over out of 4 square feet. So what I love about this problem is it forced us to actually look at this key and use that information to figure out the dimensions. And we know how to do that because we've been doing this for the past few lessons. So let's hit pause here so you can jot this down into your notes. Pop, let's just make sure we have a full answer. Area equals 8 3/4 square feet. All right, let's go to our guided practice. And now it's your turn to try. What is the area in square units of a rectangle with side lengths of 3 3/4 and 9 1/2? Ooh, so again, I told you when we have fractional parts, the numbers may look really overwhelming, but you know how to solve this. So hit pause, work through the calculations, and then I'll work through it so you can see if your answer matches mine. Okay, so let's do the reveal. You should have gotten for this problem C, 35 and 5/8. So if you got this answer, great. You can stop the video here. I'll see you in the next one. If you didn't, there's so many places to make calculation errors here. And I'm thinking about it in 3 different steps. So stay on and let's see if we can find where the error was. The first step I'm going to tell you is to convert these mixed numbers to improper fractions. That's the first thing we're going to do. So we're going to do 4 groups of 3 is 12 plus 3 is 14. No, 15, sorry. So 15 over 4. See, even I made a mistake right there where I had this 12, and in my head I only added 2 instead of 3. Very easy to make mistakes. I do it too all the time, far from perfect. Let's do the next one. 2 times 9 is 18. 18 plus 1 is 19. So if you got here, great. That's the very first step. If you were stuck on converting fractions, just get practice there. Now, in step 2, we have to actually multiply. Whew, child. Our denominators are easy. 4 times 2 is 8. But that numerator, whew, I'm going to need a little bit of space, so I'm going to put it on the side. 15 times 19. So this is another place where kids can make mistakes. 9 times 5 is 45. 9 times 1, 9 plus 4 is 135. 1 times 5 is 5. 1 times 1 is 1. So this gives me 285. So that's my answer here. Let me give myself a little bit more space because sometimes I didn't do that. I don't like that I did that. So let's give myself a little bit of space. I had 285 over 8. So check and see if you got that number, that fraction when you multiplied. So that's my second step. And now my final step, I have to divide to get my mixed number back. I can't leave it improper, so I have to divide again. So 285 divided by 8. Don't try to do this in your head. Just take a moment. Let's actually do the long division. It's okay. And I know that 8 goes into 28 3 times. That's 24. I have 45 left. 8 goes into 45 5 times. And that leaves me with 5. So my answer is 35 with my remainder 5 over 8. And that is how I got this answer right over here. Okay, so like I said, tons of different places where kids can make mistakes. So just check and see if you did have a calculation error. Was it when you converted, when you took this and turned it into mixed numbers? Was it just the multiplying to get to 285? Was that where the place was? Because once you have a mistake somewhere, it carries through the rest of the problem. But I will tell you, as someone who's graded a ton of tests, you can't get penalized multiple times. Like once you have one problem, I usually count it just that one time, and I look to see that the rest of your processes are the same, are correct. Or was it in changing that mixed number, that improper fraction back to a mixed number using division? All right, so I hope you found this super helpful. In this lesson, we're going to do a lot of stuff with finding area with fractional edges, or it could be mixed numbers that have fractions in them. So have some practice. Make sure you're showing all your work and giving yourself space to calculate. That's it for today. I'll see you in the next lesson, Math Marbles. Bye-bye.